Okay, so welcome everybody. I'm Diana Hamer and I just graduated in 2020 from William & Mary, and in my year of quarantine I've been able to write and publish not one but two books of poetry, and I am so grateful and happy to be here at the Eastham Public Library to be able to share everything with you guys. And I'm joined by a very special guest, Sandy Macfarlane, who's a renowned science writer. She's been in this field for over 4 decades, and I really appreciate her insights, and she has invaluable experience. So thank you so much, Sandy, for joining me today.
My pleasure.
So we are going to talk about nature and the environment and writing. The title of this talk is "I Need the Sea Because It Teaches Me," which is a quote from Pablo Neruda's poem, The Sea. And I think it really encapsulates both Sandy and my feelings towards the environment and Cape Cod and ocean science in general. So we are going to begin by discussing the influence of science and the use of science in our respective writing, me in my poems and Sandy in her essays and nonfiction books. And we're going to do a couple of readings from some of our books. And then at the end, we're going to have some closing thoughts about this past year and why environmental science and the doing science and writing about science is so important nowadays. So I will begin. Like I said, I have published 2 books in this past year, and I really wanted to talk about my love for both science and poetry and why I think that they're interconnected and should be seen as kind of vehicles for understanding the other. So science, you can use science to understand poems, or you can use poems to understand complex scientific topics. So I was first drawn to science because of the routine and the rhythm and the certainty of it. Because in science, nothing ever stays the same for long, but there are effective and permanent formulas and ways to discover new truths about life and the new wonders of our environment. This photo is at Herring Cove Beach in Provincetown. It's of Mark Adams, who's a GIS specialist for the Cape Cod National Seashore. 2 years ago, I was interning at the Center for Coastal Studies in Provincetown, and I jumped in on a project that Mark and Graham Geis were doing in measuring the dune elevation of the ever-changing sandbars and dunes on Herring Cove Beach. And I can talk about and show the results of that little experiment. It's not a little experiment, it was for a couple of years, but that experiment in another slide. So we really put to use the scientific method about observing the beach and learning about how it had changed in the past by looking at Google Maps and other data, and using the scientific method of experiment and results and publishing your conclusions is a formula that you can plug any topic into or any idea into, and it will guarantee that as long as you follow every one of the steps that you will get a result. So science is very much values precision and patterns and systems of data and of analyzing everything. And although it's not immune to human error and subjectivity, scientists do their best to remain separated from the influences of the people around them in theory. But sometimes it's not always perfect. One time in high school, I did a project for my science fair in 9th grade where we were given plants that had been genetically modified, and we were told to grow them under different conditions and see what would happen. And everybody had been doing, we'll grow it under blue light, or we'll grow it under red light, or we'll grow them in the dark. And then my partner and I decided, oh, we'll put salt water on them, because nobody's doing that. And we found out that no one was doing that because it kills plants. So we ended up killing our plants for my science fair, but we actually ended up winning our ecology category because we were able to portray it in a way that we were not trying to kill our plants. We were studying the effects of salt water, because as sea levels rise, we will have more and more salt water influxing into the land. So we were seeing if certain kinds of plants would be able to adapt more to it. So it's science. In that case, the data was lacking in some sort of scientific profundity, but we were able to make it relevant and make it accessible to people by thinking about it from a different perspective instead of just narrowing in on the data that we had. So in a different vein, I was drawn to poetry after I took creative writing in high school for 2 years. And my creative writing teacher, after the end of the second year, told me that instead of taking a final exam, she would allow me to write a poetry journal instead. And naturally, I did not want to take a final. So I kept a poetry journal for a month, and her comments on it were very encouraging. And I found that I enjoyed it much better than trying to keep a regular prose diary, because it can be too overwhelming and too time consuming to write out every single thought every single day. So that was a bit frustrating for me. But I've written poems for 6 or 7 years or now, but I wouldn't really at first show them to many people except for 1 or 2 friends and my professor who's on here right now. So they were the select few for many years. But like I said, with quarantine this past year, I decided that it was finally the time to get them ready and put them into a book. And part of the reason why I didn't share for so long was because, especially in high school, I was kind of the math and science nerd. I was in that kind of clumped in with that group of people. You know, in high school, there's always those groups. So I felt like it didn't really go with my brand, and people wouldn't take me seriously or think that they were any good if I were to tell them that I also wrote poetry. But I like poetry because it provides a structure for your thoughts. So when you can divide it by lines or by stanzas, so that they don't overwhelm you. And when they're short, they fit nicely into a compact and sometimes dense little present that you can then read over and over again and come to terms with what you were thinking about or what you were confused about. I love writing poems that have syllable limits as well as free verse. The syllable limit ones, like haikus and minute poems and villanelles, are a nice way to ensure that you will have a beautiful creation at the end of your writing. Whereas sometimes free verse, it can be nice to make up your own rhyme scheme or your own stanza structure. And that kind of appeals to me most when I know that I need to write something, but I can't really figure out what's on my mind, instead of knowing what's on my mind, but not knowing what to write when I go to structure. When I go to a structured poem. And this is just a picture of me reading a poem at one of William and Mary's poetry readings that they had on campus. This was in fall 2019. So the similarities between science and poetry for me is that, like I've said, both have a set structure to follow, and you can input your own thoughts and your own identity into your experiment. Less so identity with science, but definitely your thoughts and hypotheses can go into your experiments in finding conclusions. And both of them allow for the creation and the discovery of new truths, either about yourself or the environment, or both at once, which I have found, and I'm sure Sandy has found in her writing about the environment and about science. And both can make the complex more palatable by making it more creative. So this graph is the end result of my experiment with Graham and Mark up at Center for Coastal Studies. And you can see that the different colors are the different dates, but basically it's just showing an elevation transect if you're looking at it horizontally. So you can see that the sandbar would move up close to the shore, and then a new one would form behind in the pink, and then it would get black, red, yellow, green as it moves more towards the high dunes, which are up on the far left of the graph. And that was a lot of fun to make, and because it involved a lot of creative thinking, we had to figure out if we were going to do one looking down vertically to kind of show, and then have little circles of altitude that you could see, or if we wanted to do it from sideways. And same with the poem, you're trying to figure out a way to present your data, your thoughts, but should I do it in a haiku? Should I do it in a free verse or something? And it's just different methods of communicating the same information, like different kinds of graphs can communicate the same information from an experiment. And before I hand it off to Sandy, I also wanted to have a quick story that I was also inspired a lot by my oceanography courses and my environmental science courses. And one in particular that stood out to me, one instance in particular that stands out to me was when I was learning about eddies in my physical oceanography class. And you can see, I got this picture from NOAA. You can see that ideally you can see that there are lighter colors of the water, and those are kind of swirling into the rest of it. And eddies that we're probably most familiar with are the ones from the jet stream that go from the Caribbean all the way up to Greenland, and it's a very hot stream of water, but sometimes that heat gets, circled off and dissipates into the rest of the cold ocean. And I loved learning about eddies, and I thought that they were so fascinating. And it reminded me of an ex-boyfriend that I have named Eddie, because our relationship was kind of all warm and wonderful at first, and then it kind of fizzled out and became in the background for both of us. So in my book, Sensing, I have a poem called An Eddy, which is describing the scientific phenomenon of the eddy and trying to use that kind of vocabulary, but it also was me kind of reminiscing on a past relationship because the names were very similar. And now I'm going to pass it off to Sandy so she can talk about her science and her writing.
Well, thank you, Diana. As Diana said, I have been working in this field for over 4 decades, and I've been fortunate enough to both live and work in Orleans. I lived in Orleans all of my adult life except for the last 7 years, and all the summers as well. So Orleans is basically still considered my home. And to work in there and actually get paid for it was just unbelievable. But as the years went by, and actually probably even from the beginning, I kind of realized that I am more of a big picture person than the experimental type. And I agree with, I know that Diana is talking about the scientific method, and that is well established. But the scientific method also starts with an observation. And that's where the key comes in for me, is making observations. And then in the big picture world, trying to piece these observations together, sort of like a jigsaw puzzle, trying to piece all of the pieces together. And I found out that that's what my strong point is, and that's what I was doing. I also learned that taking a cue from Diana's experiment is that very often you learn almost as much from mistakes as you do from successes. And I am the proud recipient, actually, of the first, probably ever, Dismal Failure Award from the National Shellfisheries Association, as sort of a joke that they did for one of their conferences. And I was asked whether I had ever done anything that didn't quite work out the way I expected. I said, "How many examples do you want?" I said, "Just one will do." I said, "Fine." And so I gave this presentation, and it was so off the wall that nobody could hold a candle to mine. So I am the proud recipient of that. But I really do believe it as well, that things don't always go right, and scientists don't usually want to advertise that. But those are the things that drive science forward even more, is to find out what didn't work. And so I think that that's a really important part of this. The picture that I have here is looking at the Lower Cape, looking south. So you have to reorient yourself, where Nantucket is at the top of the screen and Provincetown, towards Provincetown, would be at the bottom. Eastham is in there. Orleans is so blessed to be part of an environment that has 3 separate estuaries. There's Pleasant Bay to the south, the Town Cove and Nauset system that is shared with Eastham, and Cape Cod Bay on the far right, that is the big bay that we probably all know. But we also have shoreline on the Atlantic coast as well. It is an incredible set of environments, and they are very, very different from one another. And that is pretty amazing in and of itself. And very early in my career, I did a very quick and dirty species distribution list, basically from Pleasant Bay and Nauset, and was staggering to find out the differences between the two, where some animals were very prolific in one and not in the other. And it just was one of those things that I didn't realize. And it wasn't just shellfish that I was interested in, but it was other animals as well, and predator-prey relationships. So it was a very interesting compilation, not done scientifically. It was just are they there, and in what how much were there? Abundance. Okay, next one, please. Mm-hmm. But one of the challenges, there's a lot of challenges with these estuaries, because A lot of things go from the land to the water. In fact, a lot of our problems start on the land and go into the water. But one of the most dynamic things that we have, and Diana touched on this with what she was doing in Herring Cove, are the barrier beaches. And in this case, we have two main barrier beaches. One of them is from Orleans south to Chatham, and the other one is the Nauset one that goes Orleans to Eastham. The Nauset one, is just absolutely fascinating because while most of the barrier beaches go from north to south, this one grows from south to north. And in this particular picture, and I gave a different one for Diana last night, but anyway, this will do.
This one?
This one, I'm sorry, that one, yeah.
Yeah, that one. Okay.
Thank you. This one is just amazing because it shows that there were two inlets at one point. It was in the 1993, I think, somewhere in the 90s anyway, where the beach broke through. And it was expected to break through in the very southern part where it traditionally had broken through, because the southern part had all of this water coming through, and it was coming around the cove and up, and it had to make that swing. And in this case, there wasn't enough water on the inside of the bay to push out on the outgoing tide. And that's how an inlet is formed. And it's kind of counterintuitive because you see washovers in the big storms, and you think that if an inlet is going to form, it's going to be forming in the storm. That's not the case. What happens is a set of 2, 3, 4 days of tides are pushing water and pushing more and more and more water into the inside. And when the storm passes, that tide has to go out. And the force of that water to push it out in a beach that's already been weakened by overwashes is what actually makes an inlet. And so actually this broke through at a very weak point, and it created two inlets. And then the northern one shut off, kind of closed off, and the southern one became the main inlet. And it's been that way since 1993. Right now, the beach is further north than it was when this break was done in the 90s. And it's probably as far north as it has ever been in the history of the beach. And I'm not positive about that fact, but it's pretty close that it is probably as far north as it has ever been. So I keep watching it and asking people after every storm, has it broken through yet? Has it broken through yet? And everybody says, no. But you can see by the bay, I mean, the flats all through there, that this is a very convoluted channel to try and get out. And you feel sorry for the fishermen who are going through this every day. So when I think of the big picture, I'm thinking not only of the resources themselves, but also of us, because we are interacting with those resources. And in this case, it's people that want to go out through the inlets. Okay, next one. Sometimes you get a visual representation of something that just really is an eye-opener if you understand it. And this one came to me in the, I think it was the late 80s. I'm not really sure exactly when this was taken. But the National Seashore was doing a study of looking at groundwater from a different perspective. They were looking at groundwater from how it was coming off of the land. And they had an airplane that was flying over the whole estuary in late August, because that's the highest differential in water temperature between the fresh water that stays at a pretty constant temperature in the 50s someplace, and the salt water that goes up into the 70s somewhere along the line. And the fresh water, because it's not dense, it floats on top. And so this picture actually shows the fresh water coming from the groundwater. This is strictly groundwater. Everything that goes onto the ground and then seeps through the soil and eventually comes out to the estuaries. This is a visual picture of that process on an outgoing tide. So when they're seeing these freshettes and the fresh water is just coming off, what this did is to show that on the left-hand side, there is literally a small watershed, and it's basically where the highway is, Route 6 there. That is the dividing line between water that is going to the town cove and water that is going to Cape Cod Bay. And it's this very small ribbon of land. On the other side of the cove, it's a much broader area that is being affected, that is actually the water coming from one side to the other, and one side going to Pleasant Bay and the other side going to the town cove. This helped dramatically in allowing the town, and actually the Cape Cod Commission was part of this too, to map the watersheds in the town, both of Orleans and Eastham, because you have this visual depiction of this, and it matched what they were doing with wells. And so it was really important information. But seeing it visually made it all the more easy for me to be able to try to explain it to the general public of what groundwater really was, and that everything that you put on the land is going to seep through, and especially septic systems being so important, because the nitrogen is not taken up by the septic system, but it just goes through the sand and goes into the water, and that becomes a fertilizer for what is growing in the water, and becomes problems that we see in the estuaries. So this was really important for me. So I think that's what I have for the basic slides. But all of these slides and all of this information is so complex that that's where my writing comes in, is trying to sift through all of this and trying to connect the dots for the general public, to try and make it so that they can understand some of these concepts. Okay, Diana?
Yeah, that's so interesting. I was wondering, because I know in that area, for those of you who don't know the Cape, it's like the Orleans is kind of right on the elbow point of it. And there, I know from reading a short history of the area that there was Jeremiah's gutter, which used to connect it all. But then when they built Route 6 and the highways and the houses, that was, I think, from what you're saying, a real dividing point when they started building land up in there. But I've heard that the Stop and Shop parking lot, that is where Jeremiah's gutter used to be, often floods during winter storms. Is that correct?
Exactly.
Sandy?
That's right.
Yeah.
That's right.
It says, yeah, so it's definitely, it's using the science to be able to explain to residents and people who visit just why all of this water keeps flowing in, and why their environment isn't the exact same as if they were living in Connecticut or up closer to Boston, where they were away from these very dynamic watersheds. So
right.
This was a great picture. I like this. So we're going to do a little bit of reading of my poems, and from Sandy's books. She's going to read a couple essays and excerpts, and we're going to talk about the influences of science. So for those of you, I don't know if some of you have a copy of Sensing already, but I'm going to read the first two stanzas of my poem called An Ocean of Endless Wonder. And I think it's better for me to read it first, and then I can go into an explanation or analysis of why I used the words that I did. So I will begin. What about the water makes me feel so calm? Endless waves and millions of rocks and clamshells. Stepping into the bay brings ultimate bliss. All worries with the tide ride away on boogie boards, chasing an infinite sun. With every hermit crab I find, my irritation slowly drains, replaced by awe. It is living, human somehow, inhaling and exhaling twice each day, covering imperfections until they wash away, shaping the broken and breaking the whole, moving whichever way it wants, for it pleases all. It has motives superior to mortals. So that's the first little bit, and you can read the rest of it in Sensing. But I wrote this when I was up on the Cape a couple years ago, and it was right around the time when the Sharktivity app appeared, where you could see where all the sharks were, and there had been a lot of intense winter storms the previous winter, so all of the beaches were different, and more importantly, on the ocean side, there were a lot more sandbars, which allowed for a lot more rip current scares. And I was musing about how the ocean is so wonderful and so fun and so exciting to look at, but it also has this mystery that can be almost dangerous and otherworldly to us. So it was a poem about how the ocean both brings me joy and then also gives me a little bit of apprehension and almost fear when thinking about exactly what is out there on the Atlantic side, which is what I get into in the rest of the stanzas in that poem. But When I say shaping the broken and breaking the whole, that is about the breaking down of sand or of rocks into sand, or breaking down driftwood and whatever else the storm has dragged from the land into the ocean. And then it uses that broken down material to create new sandbars and new beaches and new spits and inlets, like Sandy was talking about in one of her previous slides. And then another thing that I learned about, this is an example of a poem that was inspired by something I learned in class. So I took a modeling class, computer modeling, not a clay modeling class, where we would look at satellite images and try to determine what was going on in the picture or why there were certain clouds here and everything. And one thing we noticed was that you can take cloud cover off of the map, but in some of the pictures that we were trying to analyze, like in California, for example, and we were looking at the coastline there, it would still be hazy. And that was because of the smoke of forest fires when that satellite picture was taken. So I was really thinking about like why the wood burns the way it does, and we talked a lot in the class about the chemical reaction that causes this, that can make the smoke so thick that it appears on a satellite image, not only appears but blocks out the land below and the ponds below that we were trying to observe. So I wrote this little poem, and I will find it in my book. I should be around here. Okay. The reactant was strolling by and suddenly stopping let out a cry. Is it the phase change, that impish jester? Could she not find another to pester? But alas, he was already dry and the gleeful fire danced for the sky. So in this poem, I did use some scientific words. So reactant is the substance that undergoes a change when there's a chemical reaction. So in this case, it's the wood or the tree that has just been strolling by and has been having a nice summer. But then all of a sudden, perhaps there is a thunderstorm and a strike of lightning, or maybe there is an arsonist with a match who wants to start trouble. And phase change is anytime a substance changes between solid, liquid, and gas. And the name for the phase change between solid and gas is sublimation. So I made this poem rhyme, so it would be sublime. I thought I was very clever when I did that, but I'm not quite sure how many non-science people would get it. But I definitely, when I was writing this poem, I was trying to make it light and funny so that people wouldn't be too put off by the scientific words. But for those of the people who do know these words and who maybe are chemical engineers or chemists or something, they would know exactly what was going on and wouldn't be too put off by the rhyme. Oh, is it gonna go? Ooh. Hold on. Okay. That's okay. So I might have to, I accidentally exited out of something, but you guys can still see the screen, right? Mm-hmm. Okay, great. Anyways, so this poem I wrote when I was taking one of my tutorials. I studied abroad at Oxford, and I was taking an environmental science and sociology tutorial. And the tutor that I had was French, and she had been trained in philosophy and sociology. So she was coming at it from a non-science perspective, whereas I was coming at this tutorial from a science perspective, and we butted heads a lot because she had me write an essay about is science objective? And I went on this long rant about, yes, that is exactly what the scientific method is supposed to be. And she tried to pick apart my argument, and it was great fun, but we definitely didn't agree initially on most of the questions that she asked me. So I wrote this poem as kind of trying to engage with her perspective and trying to question or explore the objectivity of science. So it goes, no respectable scientist or honest public servant can nimbly erase their opinions from a situation. And yet everyone files their emotions away nicely in a crisis, achieving some level of empirical power. So it just kind of goes to say that, like, yes, we aren't inherently objective as human beings, but when we need to be, when, you know, perhaps if there's a public servant, like a politician who needs to handle a crisis or who needs to work with their constituents on something, they kind of have to put their own problems and their own thoughts aside and focus on the task at hand, much like scientists do when they're trying to figure out how to solve a problem. And then I have I should have mentioned, those 3 poems that I read were from Sensing, were from my book. And now I'm going to read 2 haiku from my book, The Sands of Time, which is a smaller book because they're all smaller poems. And so the first one is about the climate point. And I learned about this, again, another example, in one of my science classes. I took a global climate change course, and we talked about how there is a point of latitude that is very high up at the equator, but kind of goes diagonally towards either pole. So at that point of latitude, the precipitation is no longer rain, it is snow, which is why at at the equator, you can see, this is a picture of Mount Kilimanjaro in Tanzania. And you can see that even though it is about 200 miles from the equator, there is snow on the top of it because it's up so high that it's cold enough for precipitation to form. And as the climate changes, this climate point gets higher and higher, especially towards the equator, and to the point where, you know, if this goes on for enough time, that places that normally have snow at sea level will no longer be able to have snow at sea level because they'll just be too warm. The ground will be too warm. And the poem Climate Point goes, peaks of alpine snow and tall evergreens make the climate point distinct. So it's describing the quality of the environment where you can observe a climate point, because it isn't obviously an exact point on a map. And then this other poem kind of deals with what Sandy was talking about earlier about the outwash plains and the glacial moraines that formed Cape Cod. And for those of you who don't know, there was a glacier that retreated and dropped sediment, and as it stopped and dropped sediment, as it was melting and retreating farther towards the poles, Cape Cod and Martha's Vineyard and Nantucket were formed. And then the outside of the beaches, you can see where Orleans is down here, and then up in Provincetown, Herring Cove, where I was in the previous pictures. These sands are constantly moving up and down and changing the beach landscape, and storms can cause more inlets, so it can cause more, like Sandy was saying, convoluted areas for fishermen to go through, depending on the severity of the storm. But this haiku is called Cape Cod. It goes, the Cape's outwash plain fell quietly as glaciers retreated northwards. So wow, it's just thinking, yeah, it's a way to kind of explain all of the science of that in a more distinct way, which is really what I tried to do with my poetry, and kind of make it seem as though you're not even learning anything when you're reading, but even though you secretly, hopefully, are. So now, Sandy, I think you're going to talk about rowing forward, looking back.
When I retired from the town relatively early in my life, the Friends of Pleasant Bay asked people from the Friends of Pleasant Bay, which is a group to protect Pleasant Bay. It's a non-government organization, NGO, and they've been in the area for a long time now. They do a really, really good work. Anyway, some people there asked me if I would give a presentation at their annual meeting. I said, sure. And they wanted to see, I have a perspective of all of my work that I had worked for the town, all the time I'd worked for the town, my observations. I said, sure. So I gave the talk, and afterwards they said, well, that was really great. Can you write this down? And I said, sure. So I wrote a 40-page expansion of the talk that was dull and boring. And they said, well, that's fine, but we were thinking of a book. I said, oh, well, that's something I've never done before. And this gentleman stepped forward who was on the board of directors, who had a 30-year career at the Boston Globe as an editor and writer, and said, I'll help you. And the result is Rowing Forward, Looking Back. And I call it a clam's eye view of human nature versus Mother Nature. And it is a compendium, basically, of what happens in a coastal community, in this case, Orleans, bombarded by development over 30 years, and what happens to the estuaries and the shellfish in those estuaries as a result of the development. So it is my story, it's my working with the town, but it's also the town's story over that period of time. And then the next one.
Mm-hmm.
From there, this fisherman caught me at a restaurant one day and asked me if I would help him get his stories out. And we had been butting heads for the better part of 30 years. And in a weak moment, I said yes. And he was telling me stories about fishing offshore, which I didn't know he had done. His name is Tiggy Peluso. And he had been telling me stories about fishing offshore. I didn't know he had done that. But his stories were compelling, and they were compelling because of the time that he was fishing, the times that he was fishing, which was the cusp between seat of the pants fishing, as they were calling it, and electronics. They were going offshore with a compass, a chart, a lead line, and basically a clock. And that's how they were finding their way, navigating their way outside of the land, but they could see land, and basically a long way offshore. And it was a fascinating time where the boats could fish as much as the boat could hold. And it was before all the regulations, and it was just very fascinating. So I knew from a historical perspective that the type of fishing he was doing, the times he was talking about, were all going to be passed away with these people that were dying off, if it wasn't written down. And so from a historical perspective and a sociological perspective, I thought it was important. So I said yes. So that was Tiggy. And actually that one won an award as well. I don't remember when this took place. I think it was probably in the 90s, maybe early 2000s. I can't remember. Terry Gibbs, who lives in Wellfleet, wanted to put together a art exhibit of the concept of water, and not necessarily what you drink, but just the concept of water in any way that, or any medium that the artist wanted. And she asked me if I would write an essay for the exhibit. And I was honored to be asked, and I said, sure. So this one is called Setting a Tide Clock. The intent was to make sure I had the correct time for high tide. The directions with the new tide clock said to choose a full moon tide to make the clock more accurate. So on a cool but sunny fall Sunday morning, I went to the yacht club with the newspaper to watch the tide. Many folks might consider this exercise as wasting time and unexcited, but it wasn't at all. Sitting in my car watching the natural rhythm around me was cathartic in a most primal way. The way to check the course of the flooding tide is to focus on something dry as the tide is coming in. The asphalt my car was sitting on was adjacent to a gravel swath that doubles as an auxiliary launching area when the fancy ramp is in use. The gravel was large, not pea stone, but rather the 1-inch variety, so it was pretty easy to set my sights on a stone that was dry. It was a rather large specimen, but it was set on top of another in such a way as to make it the highest relief in the general area, about 1.5 inches above the rest of the surrounding gravel. Within 10 minutes, it was covered with water, and after another 10 minutes, it was underwater by its own height above ground. In 20 minutes, there were more than 2 inches of water where it had been dry moments before. I found another stone further up the beach and watched it for a while until it too was underwater. Then my eyes shifted to the rack line left by the last highest tide. The water was up to it, and I could no longer tell if more water was creeping higher under the vegetation until I spotted a hole in the rack line where the water was visible. With choice pieces of gravel around the hole, I could again watch to see if the water rose any higher, and it did. I checked my watch against the time the tide charts indicated for high tide and knew it wouldn't be long until the highest point would be reached. With little wind, this would be a true high tide, not a wind-driven one, a perfect day to set my tide clock. As I watched the incremental flooding of the gravel, I thought about the forces involved in this movement. The science of lunar gravitational pull on this watery planet does not convey the magic. Every 6 hours, rain or shine, day in and day out, the water moves in one direction or the other, in toward the land or out toward the sea. It makes no difference what is happening on the land. It makes no difference what is happening to the creatures that inhabit the land, including us. We can go about our daily routines and rituals, calmly or violently, in peace or at war, in winter or summer, and the tide will still come and go, just as the sun will rise and set. These are the earth's rhythms, but we have stepped back and away from them. We no longer take the time to sit and watch this incredible dance or marvel in its simplicity and inexorable power. Within minutes of the time stated for high tide, the volume in the little hole in the rack line decreased. High tide had come and gone, and the tide began to recede and move in the other direction. There was no sound or other obvious indication that a profound change had taken place, but the natural hourglass had been turned over and the drops of water were falling in the other direction. During this reverie, a single paddler glided toward the yacht club in a bright red kayak, his hooded sweatshirt pulled up over his head for protection in the chill air. He passed by a gleaming black point-snouted orb in the water, but paid no attention to the seal that had surfaced a short distance from his boat. Seals have often followed me as I rode around the water, and I wondered if this seal had been following him on his journey. The kayaker got to the head of the cove, stopped for the briefest of moments, turned around and headed back up the cove, but I didn't see the seal again. Buffleheads, a group of 5, swam in front of me, but they were spooked by a large flock of their comrades that flew close to the water toward the equivalent of greener pastures, and the small group joined a larger flock, setting down in a protected lee further up the cove. A single willet darted back and forth at the rack line on the asphalt launching ramp nearby, and a solitary gull stood on the rail of the dock, jutting out of the water. The gull preened for a while and then sat on the rail, tucking its head into its wings, looking like it was taking a sunny snooze. A few geese swam among the marsh reeds in an area known as a freshet. When I was sure the tide had changed, I left and made my way home, back to the business of setting the tide clock. As I drove up the road, it struck me that once I turned my back on the water, I returned to the land, the water but a recent memory. And yet, that which takes no orders from the creatures who think they rule the world actually does rule the world. Without the movement of the water around the globe, tides and currents, without the weather created by that movement, without the life-giving rain of fresh water evaporated from the seas, we would not survive. We take it for granted, but it is truly water that governs what happens on the land. We should pay more attention.
That was excellent. I loved how you discussed how you were watching the tide and now how it occupied so much of your thoughts. And then the moment you turned away from it, it was as if, you had just gone back to a regular day almost, and you'd only had the memory of it. I thought that was beautiful.
Thank you. This next piece is from the first chapter of my latest book, Swirling Currents. Fort Hill evokes a serene calmness, but that placid veneer disguises swirling undercurrents that will be difficult to resolve in the 21st century. They are part of a web of connected circumstances, natural events, and human activities that result in alterations to the landscape and to our perceptions. At this bucolic scene, I see the obvious beauty, but that essence is veiled by representations of something else entirely. I see the parts, but I see the whole as well, the result of a 40-year career in conservation and resource management. I see signs of how we have impacted marine resources, the habitats and the creatures that depend on those habitats. And I recognize that Cape Cod and the region merely represent the conflicts that we, in general, have with the sea and its inhabitants.
That was great. I loved hearing your perspective about Fort Hill, because that's a place that my parents and I love to go hike and to visit. And for those of you who haven't been there, it is up on a hill overlooking the Atlantic Ocean and the barrier beaches, and there are trails that you can take down into the marsh and walking around on the very edges of the marsh, or you can go back into the swamps, or you can just walk around a vast open plain up there. So it's a very beautiful area. I thought you captured that very well in your writing.
I wrote this book because it struck me that there was a disconnect that people had between what they were seeing and the reality of the Cape, and that there is also a shifting baseline that a lot of people have, that when the turnover rate on the Cape is just phenomenal. And when people move to an area, they see it as it is at that particular time, and they think that that's the way it always was, and that's the way it always should be. And if nothing else, the Cape is one of drastic change, and it's changing before our very eyes on a daily basis. And people don't necessarily understand that. And so and I also felt that it was that the issues were much more complex than what I had written first in Rowing Forward, which stuck to the estuaries, that I had to go offshore again and show what was happening to all of these things, the whales, the fish, the turtles that get stranded, the shark seal dilemma, the lobsters that are moving, all of these things, and they're all interconnected. And I wanted to try and explain these connections and interconnections and show the big picture of why we should all care about this. And it's all under the umbrella of climate change, which is scary anyway. So that's why I wrote Swirling Currents.
Yeah, that was exactly what I was going to close with too, is that the Cape is such a dynamic environment. And you're right, a lot of people who visit come and then are surprised next year that the beach is in a different spot, or that their parking lot is half gone and they don't know what happened there. And so it's important for those people who know the science and who understand either the specific environment that they're writing about or general topics about, you know, coastline change and erosion and, you know, the dynamics of sandbars, or even of the animals that live in those sandbars and estuaries, and are able to explain that to people who are just visiting or perhaps have never been and would like to go someday. So that way they can understand that, you know, even before climate change started rapidly and exponentially speeding up all across the globe, the Cape was always a changing environment. And with, like you said, the advent of climate change affecting here more, it's only accelerating all of those original changes and affecting the warmth of the water and the strength of the storms. And it's important for those of us who have knowledge and vocabulary to be able to explain the environmental science and the ecology and the physics behind everything that's happening every year, and every year, even every month on the Cape. So with that was all that I had. And I mean, yeah, I think Sandy, you answered any questions that I had thought of while I was reading Swirling Currents before in your analysis and explanation of Swirling Currents. So thank you for that.
Thank you.
Yeah, so I guess that's all. I would like to thank you guys all for coming. It means so much to me. And thank you for Sandy for joining me, and to the Eastham Public Library for helping me host all of this.